plot the curve of the function y equal to x cube minus 12x minus 16. To plot the curve of the function y equal to x cube minus 12x minus 16, first we have to find out the intercepts, that is the x intercepts and the y intercept. The given function is y equal to x cube minus 12x minus 16. First we have to write the function in terms of factors. So x cube minus 12x is equal to minus 16x plus 4x minus 16. So if you take x common, here you will have x square minus 16 plus, if you take 4 common, x minus 4. So if you take x minus 4 common from these two, then in the bracket you have, here you have x plus 4. So x into x plus 4, that is equal to x square plus 4x, and here plus 4. So this will be equal to x minus 4 into x plus 2 whole square. And for x intercept y equal to 0. So if you put y equal to 0, then x minus 4 into x plus 2 whole square will be equal to 0. And if x minus 4 into x plus 2 whole square will be equal to 0, then x will be equal to 4 and x will be also equal to minus 2, because x plus 2 whole square is equal to 0 or x plus 2 will be equal to 0. So x will be equal to minus 2. So you have two x intercepts. One is x equal at x equal to 4 and another x equal to minus 2. Then we will find out the y intercept, and for y intercept x will be equal to 0. So in the equation y equal to x minus 4 into x plus 2 whole square, if x will be equal to 0, you put x equal to 0 here. So 0 minus 4 into 0 plus 2 whole square. So this will be equal to minus 4 into 2 square, that is equal to 4. So 4 into 4, 16. So minus 16. So for y intercept you have minus 16. So y intercept is 0 and minus 16, and the x intercept is 4 and minus 2. So at y equal to 0, x equal to minus 2, and at y equal to 0 also you have x equal to 4. So the x intercept coordinates are minus 2 0 and 4 0, and y intercept coordinate is 0 minus 16. Then we will find out the critical points. For critical point, the first derivative of the function is equal to 0. The given function is y equal to x cube minus 12x minus 16. So the first derivative of the function with respect to x, for x cube it is 3x square, for 12x it is 12, so 3x cube minus 12. And for the critical point, we know the first derivative is equal to 0. So 3x square minus 12, that is equal to 0. So 3x square will be equal to 12, or x square will be equal to 4, or x will be equal to plus minus 2. So we will get the critical point, one is at plus 2 and another one is at minus 2. After finding the critical point, you have to test for the concavity of the function. The first for concavity we have to find out the second derivative. The first derivative is 3x square minus 12. So the second derivative will be equal to 6x. And at the critical point 2, if you put 2 here, this will be equal to 6 into 2, that is equal to 12, which is greater than 0. So at 2, the second derivative is greater than 0. And we know if the second derivative is greater than 0, the function is concave upward. So at concavity of the function or concave upward, the function will be concave upward at x equal to 2, and at x equal to minus 2, if you put x equal to minus 2 here, this will be equal to minus 12. So the second derivative will be less than 0. So the function will be concave downward or convex upward. Now you can plot the graph of the given function y equal to x cube minus 12x minus 16. You have two intercept of x, one is at minus 2 0, another intercept is 4 0, and the y-intercept is 0 16 minus 16. So y-intercept is 0 minus 16, x-intercept is minus 2 0 and 4 0. And we have found out that there is critical point at plus 2 and minus 2. You see, you will have critical point minus 2 and plus 2. And at plus 2, we have found out the second derivative is greater than 0. So the function is concave upward. You see, the function is concave upward, and at x equal to minus 2, the second derivative is less than 0. So the function is concave downward or convex upward. So in this way you can plot the graph of the function y equal to x square minus 12x minus 16. Thank you.